I'm Chris. I'm a production engineer at Facebook. I spent most of a year working with the Instagram team to migrate Instagram into Facebook. And this is a slightly less technical talk. There's going to be a little bit of a tech deep dive onto one of the systems that we wrote and we open sourced for you. But this is much more of a kind of ethics and ethos of kind of like why and how and what were the best things that we learned from our integration process and how you can take advantage of them in the future. So, we're going to start with a bit of background about Instagram. What is it? How does it work? How does it not work? And so on. What did we do? The details of the project on kind of the processes we went through and so on, and what we learned from it. Both what did Facebook learn about Instagram? What did Instagram learn about Facebook? And what can you learn from our experience? I mean, the great thing about coming to a conference like this is you can see how other people did things, and you can learn from their mistakes without having to make them yourself. I find that very important. Another really important thing is I put a timeline across the bottom, so you can see the blue star, like the left-hand side is now and the right-hand side is when you get a break. So if you got a little bit of a countdown to coffee just to try and keep you. Okay, so a bit of background. Hopefully most of you have heard about Instagram. Instagram is this kind of awesome iOS app that lets you take pictures and apply filters and makes your pictures look really cool. You have all this social aspect of friendship and following, and it's a legitimate social network in its own right, obviously. Acquired by Facebook in 2012, and everyone knows about the iOS or the Android app, and everyone kind of presumes that's Instagram, right? Well, it's kind of true. But in reality, Instagram is like a really big server-side application, right? It's Django running on Ubuntu with Postgres for its database, a bunch of Memcache, a bunch of Redis, a bunch of other things at the time. And this is the kind of pre-integration architecture. It's kind of traditional Linux app servers, databases, caching tier, and so on. When we started this process, it had about 100 million monthly active users. That was kind of early 2013, but it was still going through this process of incredible growth. It's an interesting challenge scaling a system that's growing, but it's an even more interesting challenge migrating and scaling a system at the same time. When you plan your migration, you say, okay, so X of these over here means Y of these over here. It's like, sure, what about when like twice as many people need to hit that? So you have to kind of include these things in your calculations, because by the time we were in this migration, we'd easily double to 200 million and beyond. Much of this growth happened whilst we were doing the migration, and it's kind of scary. I mean, I know some of the things that I'm going to talk about today, if people had told me how difficult some of these things were going to be before I signed up to the project, I might have thought twice about signing up to the project, because it definitely wasn't a small thing. Especially in 2012, when we had an infra team of 4 people. When Instagram got acquired, there were 4 people doing infrastructure. They supported, thick end of 100 million users, and it was tough. I mean, they'd had to leverage a bunch of automation and mechanizing to try and allow the magnification of people to solve this problem. But by 2013, they'd grown to about 8. And one of the things that the Facebook acquisition did for Instagram was allow them to find and hire the correct people quickly. Facebook has this kind of giant fire hose of people applying for jobs, and a lot of them get hired and go into boot camp. And then Instagram kind of allowed to tap into that to enable them to be like, hey, this guy seems really interesting. He's got the right kind of skills and attitude, and he's really interested in Instagram. Maybe he should come over here rather than looking at something else. And by 2014, we'd scaled the team to 20 people. And we were thinking, okay, this is a reasonable sized infrastructure team now. We've got a lot of people involved. It's all good. The pre-integration architecture was EC2 Classic, S3, ELB, auto-scaling. Not a huge amount of auto-scaling, to be honest. Most of our kind of infrastructure was EC2 Classic, and obviously a ton of photos in S3. ELB to kind of point the people coming through the door at the right place at the right time, and so on. It's not that we couldn't make use of the fancy Amazon hotness that they were releasing. It's just that most of it wasn't around when Instagram was solving these problems. I mean, I see nods in the audience where Instagram was kind of scaling its infrastructure faster than AWS was scaling their infrastructure at the time in terms of tools and technologies. And often Instagram would like put a bunch of effort into solving a problem and resolving a situation that was suboptimal. And then a couple of weeks after they ship it, Amazon are like, oh, hey, you can just get this as a service from us now. It's like, damn it, we did all this work, and now you can just buy it from Amazon. It's brilliant, but it can be stressful. I mean, it's kind of vilifying looking at the way, you solve a problem and you work out how to do it and you work out how to make it scale, and it's really cool. And then you look at how Amazon did it, and it happens that they did it almost the same way as you did. It's like, okay, we were probably along the right lines. Hopefully you'll get some of that from this. But the kind of most important thing about working with Instagram, they kind of have three kind of core ethics. I mean, Facebook makes the world more open and connected. Instagram is there to record and share the world's moments. But they do this by providing and kind of baking into their entire culture a set of kind of core methodologies. The most important one being do the simple thing first. The first thing that Mikey says to you on your first day at Instagram, he's like, hey, so we do this thing, we do it our way, we make it work, we make it good, and we make it fast. But most importantly, do the simple thing first. And this is something that people have said this for decades, right? Keep it simple, stupid was Kelly Johnson at Lockheed Skunk Works, and they built the SR-71 spy plane. I mean, that's an amazing piece of equipment. He famously took a typical aircraft mechanic's bag and sent it over to the people that were designing this thing, and he said, hey, so these are the tools you have. Make sure we can maintain that airplane with these tools. And the guys were like, what? There's no, this isn't a fancy toolkit. And he was like, keep it simple, A countryman of mine, Colin Chapman from Lotus Sports Cars, simplify, then add lightness. He kind of said, make the car as simple and as easy as possible, and that'll be a good thing. And this plays out today with things like Ruby on Rails with the convention over configuration and don't repeat yourself mentalities that we see in software engineering. This is not new. It's pretty important, and I think people sometimes lose track of that. I'm not going to go into much more detail about Instagram because Mikey's actually already done it. There's a URL. It's the top Google hit for Krieger QCon 2013. When Mikey went into a bunch of detail about how they started, the initial scaling, the kind of, we released Instagram on one server and then it got really popular, and then they phoned up their colo people, and their colo people were like, oh yeah, we can do that in about a week. And he's like, I need this tomorrow. And they had to learn what AWS was real quick. He tells a story about someone said, what's your load average? And he's like, what's a load average? They kind of went from 0 to 100 really, really quickly. That's a great talk. You should totally check it out. But what did we do? It was a team of people. This was very much a team effort. And there's an article about that as well. Wired came in and took this picture where we all kind of got to stand, and they were like, hey, say something funny. It's like, yeah. You see Pedro on the left-hand side, who spoke earlier. This was the core team for this project, and we kind of developed integration as we went. It wasn't necessarily hugely planned out from the beginning, but we knew which mentalities we wanted to fit to, and we knew what the end outcome needed to be, so we kind of worked it out. But the first thing we did was we started adding one-off software as a service type features. Things like site integrity, anti-spam, community operations. Facebook has world-class systems to solve these problems, and when Instagram's anti-spam system was a regex on the word follow, it's like, oh, sure, and then people start using like a backslash, a pipe, and a forward slash to make the W, and your regex gets a little bit more complicated, and it gets more and more complicated until your anti-spam problem is how do we run regexes faster. It's like, yeah, we probably don't want to be doing this, and then Facebook have this awesome anti-spam system, so they said sure, and they provided us a way to call Sentry and Sigma and these awesome world-class anti-spam systems via HTTP, HTTPS, and we kind of used Facebook systems as a service, and it worked really well. And then, community operations are the people that look at the pictures that get reported, and it's like, does this violate terms, yes or no? They're the people that do that see the terrible things so that we don't have to, and I'm really, really glad they exist. And Facebook, again, has a team to solve this problem. It's, it's a 24/7 team separated all over the world, and they use common tooling, and Instagram were like, can we get some of that? And they're like, sure, pour everything through this service, and the same people will check the guidelines and so on. And it worked pretty well. But as we start to look at more and more stuff, it soon became pretty clear that there were definitely enough internal systems that were compelling enough to make us want to do a full compute migration. And it was like, we're calling so many things just over software as a service. We might as well kind of move everything into here and get everything for free, rather than poking holes in the system to make one-off calls. So we kind of sat down and we said, okay, it's getting to the point now that we should probably do more than we currently do. So what do we want to do? And the plan was that we were going to move all, well, as much as sensible, of the systems that we had in AWS, and to try and migrate them into Facebook so that we could help our developers implement things faster, basically. Web servers, databases, caches, application servers, Redis, the whole lot. And this term Instegration was coined. I don't know who invented it. I think it was either Mikey or Rick. But it's been defined in the past as the process of moving Instagram's infrastructure from Amazon to Facebook's data centers. Another quote from that article is that the users were still in the same car they were in at the beginning of the journey, but we've swapped out every single part without them noticing. And we did actually end up doing this with zero migration-related downtime. It was like a huge job, and we did have some downtime during the migration process, but we're certain it wasn't directly related to the migration. It was like, Amazon had a problem. We couldn't kind of deal with that problem quite so quickly. But when I say we swapped out everything, this includes the operating system. I said Instagram was Ubuntu on EC2, quite heavily and quite extensively Ubuntu on EC2. Well, Facebook is a CentOS shop, so we were like, okay, we need to kind of, make that change where we need to. But not only that, EC2 uses Zen for its virtualization, or some form of Zen for its virtualization, and well, Facebook doesn't do virtualization, so we even moved from a virtualized system into an LXC containerized system that Facebook uses internally. It was quite a challenge. How did we do it? This is kind of the interesting part. Well, simplification. Simplification was key to all of these processes. Kind of everything we did, the first thought should be do the simple thing first. We kind of adhere to that methodology throughout, because it's kind of key to being part of Instagram. I mean, we'd go and we'd be like, okay, so this subsystem, how do we move this across? And Mikey would be like, well, first off, can we just copy it? It's like, well, not quite. And he's like, okay, what's the next simplest thing we can possibly do? And it was very much a case of taking every system and ridiculously simplifying it to be the smallest amount it possibly could. We kind of had written on the wall in big letters, keep it simple, stupid. It was like, that was the kind of flagship mentality. But that meant removing all the cruft that had been generated over the years. Now, who's had like an alarm come through on the pager and it's like, this system died. But then you look at your application statistics and they didn't really change. I mean, nothing else is failing. And it's like, well, if that system died and no user problem was caused and nothing else seems to have had a problem, was that system even needed in the first place? Like maybe if it's, maybe if it has a problem and if a tree falls in a forest and no one hears it, well, it probably wasn't required in the first place. So we looked at systems we had that were overlapping. So we used Memcache and Redis and Cassandra for a variety of reasons in the past. And, it was like, we feel like we could get away with just two of these things. We looked at some of the Redis use cases and it was like, it's running on Redis at the moment, but it looks like we could probably do that with Memcache if we make this small tweak here. Or, we kind of looked at other use cases and it was like, that could probably fit into Cassandra. So we decided that we would try to push Redis towards Cassandra and Memcache instead, and see if we could reduce the amount of Redis use we had, just because it meant one less thing to migrate, and it made it a little bit easier. We built a homebrewed push and caching system for Zookeeper for configuration. So we have this daemon that runs on every machine that collects configs for that machine from Zookeeper, and it was like, okay, how do we make this simple? Like, if Zookeeper's broken, we don't want everything else to break. Like, new configs, sure, but why can't it just read the existing configs from its local cache? So we built a local caching system for keeping a local copy of configs outside of Zookeeper. We looked at the various kind of machine pools we had in auto-scaling groups and behind load balancers, and it was like, we had two API pools, one for external clients and one for internal clients, and it was like, they kind of do the same thing. There's no particular need for them to be separated, and we looked at the profile and the statistics for like, the API endpoints are slightly different for internal versus external, but there didn't seem to be any reason not to merge these, so we merged all of our API machines into one pool. That simplified our load balancing configuration a whole bunch, which was good. And we moved everything into configuration management. We happened to choose Chef, but my personal opinion is that you could choose anything. I think configuration management is a thing that's important. It's not necessarily Chef or Puppet or Ansible or Salt. I don't particularly care. I think actually having good configuration management is the thing that matters. I think that's the thing that helped us. So we started off by doing a whole bunch of work to take the selection of AMIs that we built over time and to kind of chefify each one of them. So it was like, okay, it's a web server, right? It takes the standard AMI and applies the web server role in Chef. Database server, standard AMI, database role in Chef. To the point that we got to the end and we were like, the AMIs are pretty much exactly the same as what Amazon provide. We don't need any customization at all in that situation. It was like, that's probably a good thing. So you phone up Amazon, you fire up Direct Connect, you replicate your stuff across, and you're done, right? How hard can it be? No. I wish. It turned out the first thing we had to do was move to VPC. If anyone has an old school EC2 account, EC2 Classic and EC2 VPC are very different things. Instagram was kind of first set up when EC2 Classic was the only option. So it's not like they chose to use Classic for any particular reason. It's just all that was available. VPC is awesome. It's pretty much a better system in almost every way. I can't think of any reason for anyone not to use VPC. VPC is like it's definitely the future. If you haven't already migrated to VPC, you totally should, and I can show you some software that will help you if you need it. But it's pretty much better in every way, and configuration management paid off immediately in this case. Like we'd gone down the route of rebuilding all of our machines as configuration, managed images rather than snapshot images, and all of a sudden it was like, well, we knew everything was going to work for a start. Like all of those things that have been running forever, and you've just been kind of installing updates and so on. Well, we knew that everything was going to be fine, and it's all good. So, we do this first move from EC2 into EC2 VPC, and then after that we get to make this hop from VPC into Facebook Direct Connect, and that's Facebook Data Center, and that's where Direct Connect comes in really handy, because it's quite easy to take an Amazon Direct Connect and rig it up to your data center, as long as you've done your IP addressing right and you've reserved the addresses on the correct side of the bridge. You can tie your two networks together, and that makes things an awful lot easier to work with. Except it's not quite that easy. If you're trying to move from Classic to VPC, they're two entirely independent systems. There's no simple way for you to address your machines on one side from the other side. You have public addresses in both places. You have private addresses in both places, but the private addresses are on disparate networks, and you can't necessarily do this addressing. So we built Netty, and Netty is a dynamic IP tables manipulation daemon. So in our case, it overlaid a /18 mesh on top of all of our machines, and allowed us to address machines using the Netty address rather than either the public or private Amazon addresses. So Netty would machines would register themselves with Zookeeper. Netty would be sat on every machine waiting for those registrations, and then it would dynamically alter that host's NAP table to say, okay, this machine just registered itself in EC2 Classic. This is its private address. This is its public address. This is how I need to understand how to get to it. Because I'm also in EC2 Classic, I can just use its private address, right? Like that's how things always used to work. That's brilliant. When a VPC machine registered, it was like, oh, I'm already in VPC. I can use its private address. That's also fine. That's the 192.168 address that we applied just got natted to another RFC 1918 address, and everything was cool. What got difficult was when a classic machine tried to talk to a VPC machine, and the VPC machine kind of spins itself up. It announces itself to the cluster, and Netty says, "Oh, cool, you're here, awesome." Oh, except I'm in Classic, and you're in VPC, and your 10/8 is different to my 10/8, and I can't talk to you. So in that case, I need to use your public address, and Netty would understand this and would choose to use the public address for traffic where the private address wasn't possible. And the last thing it did was it dropped everything else. So at this point, your security groups are pretty well open, because you don't want to be manipulating security groups constantly as machines come and go. Like, that's generally recognized as a bad thing. So we kind of opened up security groups a lot and had Netty manage firewall rules to stop anything we didn't want to happen. This took a bit of writing. It wasn't a trivial process, but fair play to Nick. We actually did this migration in about 3 weeks. It was really fast. I mean, we did a lot of upfront work to make sure it was ready, but then the actual cutover from Classic to VPC was only like 3 weeks. It was really good work from Nick. The next thing we looked at was infrastructure as code. How is infrastructure code? Well, configuration management kind of makes the configuration of your infrastructure code, but some people use EC2 or AWS, and you click through the UIs and you add machines to pools and so on, and it's great if you have a few machines. When you start to have tens, hundreds, or even thousands of machines, kind of manually creating machines and adding them to pools becomes a little bit onerous. It's not long before someone clicks the wrong checkbox and uses the wrong image or passes the wrong configuration management profile in, and now you've got a database server trying to serve web traffic, and it's going to be a nightmare. So we already had a bunch of automation around this. Remember I said Instagram had like 4 or 8 people working on infrastructure? Well, the way they kind of made it work was to treat all of their infrastructure as code, to be able to revision control between any point in time and any other point in time, to understand what had happened, like who added the machine, what type of machine did they add, what pool was it added to, and so on. And we very much kind of cared about this already. So we had to sit and we sat down with a bunch of Facebook people, and we mapped each EC2 instance type to a Facebook computer type. Now, EC2 has like hundreds of instance types now, I guess. We used relatively few of them. We tended to try and use the ones that aligned to larger instance types. We generally found that we got more performance from larger instances than smaller instances. Facebook's internal network has nowhere near that many kind of variations of machines. So we sat down and we said, okay, this database maps to this database server. Web machines map to web machines, but like cache machines map to cache machines. How does Cassandra fit into this? Like, Cassandra needs to use some of the database aspects and some of the cache machine aspects. So we did a bit of basic performance testing, and we sat down and we said, okay, this cluster has to have this many machines, it has to have this much RAM, this much disk space. Mathematically, that means we need this many Facebook machines. Now, that's presuming we can run Cassandra hot enough to kind of get this machine to 80% usage. And we sat down and we did the perf testing to make sure it was the case. And yeah, it was. I mean, we made sure everything lined up, and it was like, okay, now we know what we need to do. So the way EC2 works is you have a kind of big machine. It's cut up into instances, and inside those instances, some kind of configuration management manages what's going on with the instance, right? You kind of don't care what happens on the host. You have no visibility into it. Amazon do all of that for you. Usually they're pretty reliable. That's generally a good thing. You get to control what happens inside your instance. And when we moved into Facebook, we were like, okay, Instagram use Chef, Facebook use Chef, great. Once again, how hard can it be? But no, you end up like Instagram Chef manages the host file to make sure certain things are resolvable without DNS. Well, Facebook Chef also manages the host file to make certain different things are resolvable without DNS. It's like, oh, crap. And Instagram Chef also has to work inside EC2 for the transition period because we didn't want to have to like fork the configuration management repository and then have to make changes in both places. It was like, no, you make one change in one place and it just works for both. Maybe you have to special case a few things, but making sure that the same configuration management worked in both places was really important to avoid having to retrain 20 infrastructure engineers to make changes in different places and all of that. So we ended up building this system where a Facebook machine would run one container. And Facebook Chef manages the host, and that does everything it needs to be able to run a container. And then inside the container, Instagram Chef runs and manages the guest. And it kind of has free reign to do whatever it wants inside the container. It can, if it wants to screw with the host file, sure, go for it. If you want to add DNS suffixes to resolve.conf, yeah, that's not a problem either. You kind of get, as much control as you want. Posit LXC doesn't allow you necessarily to change everything. I mean, we ended up writing some interesting hooks from the guest to the host such that the guest could control parameters in the host's chef run for things like sysctls and stuff like that you can't necessarily specialize inside the LXC container itself because what does how does a sysctl really apply to a container if you have two containers on the machine? Now what happens? It doesn't really work. And we also had to rebuild one Amazon system that we'd relied on quite extensively, and Facebook just didn't have a solution for. And it sounds really obvious, but Amazon's instance tagging is really powerful. The ability to provide to apply arbitrary key value pairs to instances and just say, hey, this instance should be known as this friendly name, and don't worry about DNS, just use these known as tags. Well, Facebook didn't have a system like that, so we ended up. I spoke to a bunch of people and I was like, hey, should I use some fancy, I could use Redis or I could use Memcache, and someone was like, why don't you just use MySQL? It's pretty good. So I ended up writing this system with MySQL. I mean, it might, it's pretty web scale, right? So now we're ready to move. We've got everything set up. We know what we're going to do. We have instance tagging available. We can use our friendly names like we're used to in EC2. We have Chef running on the guests, and the Chef running on the guests actually makes a host file that reads its content from this tag database so that you can access a machine based on the name you gave it in a tag rather than having to resolve its IP and so on. Now we're ready to move. But at the same time, we had another question. Someone said, well, when you write a picture to S3, it's a HTTP post, right? HTTPS post. It's like, sure. And they said, well, the Facebook system for Everstore, Haystack, is just a HTTPS post. Why do we have to move the infrastructure inside Facebook before we start using this? Can we start using Haystack to store pictures before we make the move? Because there's no reason that the compute has to be close to Haystack. We already have this software as a service endpoint. It's effectively the same thing as you do when you upload an iOS photo, or upload a photo from the Facebook iOS app or the Facebook Android app. Why don't we take advantage of that first? And we rapidly realized that we could change the storage engine without actually changing the compute, and we could change the compute without changing the storage engine as well. So we built a system to allow us to kind of move the storage, move the upload path, or the default upload path. We actually uploaded to both for a little while, and just slowly move over the percentage that we're getting written to Facebook, and then dial down the percentage that we're getting written to S3 in parallel with the process of moving users and traffic. The process of moving users and traffic is actually quite simple, right? Replicate, test, cut the master over, test it again, next service. I mean, I think the important portion of this is the testing cycle, right? You start your replication stream and everything looks great. You should probably actually test that the slave is processing those requests and not just dropping them on the floor. I mean, a couple of times we fired stuff up, we pointed it across, and it was like, yeah, it's working great. And someone's like, why is the file not being updated on the disk? It's like, yeah, okay, we should probably look into that. Actually, monitoring these, these test processes and understanding kind of success and failure conditions is really important at this phase, because there are some systems that the replication is quote unquote successful because the master has sent the update to the slave. It doesn't actually mean the slave has received the update and persisted the update or anything like that. It's, this test repeatedly process is really important. And you move things over one at a time. Don't try and move everything in one go. It's also probably a bad idea. You ever see the fairground attraction where the guy has like a big long stick with a plate spinning on the top of it? Well, he can do one and it's real easy, right? He does two and it's a little bit harder. Once he's up to like 10, no, it's probably not a great way to approach this. So we also worked out which of the things that were most important to be located close together. Now, obviously, latency between your web server and your cache service is really important, right? So it probably makes sense to move the cache and the web approximately similarly timed. At the same time, latency between the web and the database for a cache fill is also just as important. But now you're up to like 3 things moving at once. I don't know. It's probably not so good. It was kind of lucky for us. We were based in US East in AWS. US East and Facebook's Ashburn location are actually really, really close to each other, both geographically and network-wise. We had a lower latency between some availability zones and Facebook than we did between some availability zones and some other availability zones within US East. The fact that they were effectively, quote unquote, the same place was really useful. So we're going from Django, Ubuntu, Postgres, Memcache, and Redis. And what does it look like kind of mid-move or after the move? Well, Postgres and Wally is a pretty kind of well-known replication system. It works really well. Cassandra has great clustering. Redis has replication. Replication trees in Redis work really well as long as you avoid that BG save when you attach a slave to a new master. It's like you don't want to be doing that if you can avoid it, but it's not usually a problem. You can use DNS to redirect the traffic from one place to another as required. And this is much more like what we ended up with. So we were still running Django, we're still running Postgres, we're still running Memcache, but as I say, we moved a lot of stuff from Redis to Cassandra. We moved the operating system from Ubuntu to CentOS, and it kind of became a simpler system because we depended on less. We depended more on things that we were more comfortable with and less on things that we weren't. The key, absolutely key to this was if it's not needed, we don't do it. Now, we talk about simplification and keep it simple, stupid, and I'm going to say this a lot over this talk because I think this is really important. But, we found ourselves occasionally in meetings, somebody will say, oh, while we're here, we should change this thing as well because it'll be much more useful in the future. It's like, no, don't do it, seriously. If it didn't need to be done yesterday, it doesn't need to be done today, unless it's an emergency. And if it's an emergency, we should pause the migration and fix the emergency, right? Like the process of resisting, while we're here type moments was really important. And I'm going to put my hand up, and I see Pedro at the back of the room because Pedro pulled me up on this a couple of times during the migration. I was one of the people that said, hey, while we're here, we should just fix this. And actually, we tried to avoid that, and over time, it actually worked out really well. I completely agree with that process being the right thing to do. But what did we need to change? Well, topology was really important, right? Like the application server and all of the systems that make up Instagram had never needed to worry about their data center before. They were just all in US East and everything was fine. Well, that's obviously not the case anymore. The locality is important, and if the master's already been moved to the remote data center, but you still have a local slave, you should do reads from your local slaves, and having your application understand its own topology was really important. That we hadn't necessarily been in a problem to need that before, so we ended up doing quite a bit of work about kind of making sure everything knew where it was and making sure everything would prefer local replicas for things where possible. Like it seems obvious, but it's not necessarily one of those things you consider right out of the gate. Failure modes. Failure modes can be a bitch. There are some things that work really well that migrate really badly. Everybody's familiar with Memcache, right? Like everybody's used Memcache. It's one of the kind of success stories of recent open source software. But Memcache has this awesome operator called check and set, CAS, right? So it's like, hey, check if this value is the right one, and if it's not, set it. It's all good. Well, if you're in the process of replicating Memcache from one place to another, you tee your sets to the other place, and you do your gets locally, and it's all good. How do you tee a check and set? It doesn't really work, right? You execute it in both the places, well, but then that's not necessarily the right thing to do. You end up with your slave having to run a different operation to your master. It's like, this is kind of, we didn't estimate for this problem to begin with. It was just like, well, we just put the sets over there and everything's fine. No, like be aware of some of these crazy things that can happen without you realizing, and sometimes it doesn't go to plan. And at this point, you're often in the danger zone when you find these things happening. Like the most dangerous time for your migration is when you have this kind of hybrid locality of half of your systems in one place, half of your systems in the other. If things go wrong, knowing whether the path is to fix forwards into the new system or whether the path is to revert back into the old system, and knowing when to make that decision for the safest point of the transition is quite important. And a couple of times I was lucky I sat right next to Nick while we were doing this, and a couple of times he'd kind of look over at me and he's like, I'm about to run this script. As soon as I press enter, we fix forwards into Facebook instead of moving back into EC2, right? And I'm like, okay, go for it. Hopefully it's not 4 o'clock on a Friday. And even seemingly simple things become a problem at this point. I mean, we had a lot of connectivity between Facebook and AWS, like a huge amount of direct connect capacity. But even that was still, sometimes it was a little bit shady. It was like, why did Amazon decide to do this network maintenance at the same time as we decided to move a database master? Fantastic, we kind of knowing the point of the process at which, the point of no return was really important to us. And, we got pretty good at it by the end. It was just kind of like a tap on the shoulder, okay, and then we'd go. But I think it's important that minimizing this amount of time when you kind of have one leg either side of the gap is a good way of minimizing your risk. I think this is definitely the most risky part of the migration. You end up with the risk of split brain systems and things like that. It's much more hazardous in this kind of environment. And again, more kudos to Nick, who actually did a lot of the migration itself, like actually did a lot of this, promotion of masters across the gap and so on. We were only actually in this position between VPC and Facebook for about 2 weeks. That was like a really impressive kind of rate of progress. Again, well done, Nick. He's not here, but well done. So what did we learn? I'm going to split what we learned into 2 things: what went well and what went less well. So what went well? Well, speed. The migration from Classic to VPC and from VPC to Facebook were both really, really quick. And as I say, minimizing the amount of time in that hybrid kind of danger zone environment is really good, because that's the time where a network event causes the most upset to the system. Well, if you can just minimize the amount of time that you have that level of impact, it's a good thing. And we did that pretty well. Performance. The new Facebook machines we were moving on to were really fast, like really fast. Facebook's Open Compute hardware teams have done a really, really good job. The latest generations of hardware is pretty impressive. Amazon actually came out with new spec machines whilst we were doing the migration that might have made the gap a little bit less clear. But if you look at from the time when we were in EC2 Classic to the time that when we were fully inside Facebook, one of the core kind of hot path functions it's like called for every feed load in Instagram, ridiculously high core rate function. The latency in that one function dropped 75%. There was just like an immense kind of performance difference being able to move to these kind of huge machines, high-speed networking, low latency, low jitter, Facebook's internal system was really, really good. Software as a service. Many Facebook teams want to work with you when you get acquired at Facebook. It's like, oh, look, new hotness. Yeah, they're really cool. We should work with them. And a whole bunch of people came and offered us solutions and offered us answers. And it was just like, yeah, we have this thing. You should totally use this. And sure, we adopted a lot of them. Instagram are in the business of recording and sharing the world's moments. They're not in the business of mobile crash reporting or, data analytics or logging. Facebook already have world-class systems for mobile crash reporting, data analytics, logging, all of these things. Like, just use them. I mean, if if it's not your core competency, why would you want to be involved in building these things? We could, just take advantage of the ones that we already had. It was pretty good. Security. Facebook has an awesome security team. Facebook's security team are really, really good. And by kind of being inside the Facebook infrastructure, Instagram can kind of piggyback on top of that. Now, hands up, who remembers where they were when Heartbleed was announced? Yeah, I'll tell you exactly where I was. I was in a hotel in Cape Town, South Africa. It was 2 a.m. I fired up I'd been out for the night. I fired up my laptop on hotel Wi-Fi, opened up the VPN, and every time I tried to type on my shell server, I was like, what the heck? This is terrible. So I run MTR between my laptop on hotel Wi-Fi and my dev server in Oregon, and I had a 400 millisecond ping and a 95% packet loss. It was just that wasn't looking pretty. Facebook's infrastructure team just solved so many of our problems in that situation. It was look, we still have people in California. It's not a problem. We're going to get this fixed. But the Facebook team were okay, we've already started the new build of OpenSSL. It's this process is ongoing, and it just we get really good at solving these security problems. The fact that Instagram can leverage that same goodness is fantastic. Growth. The service, as I said, grew dramatically during the migration project, and we dealt with it. We dealt with more than just the growth of the service. As I say, the new Facebook machines were way fast. We kind of knew how fast they were going to be. We knew how many we thought we needed. We looked at kind of projected growth rates, and it was okay, we're going to make this work. But then product come along at the same time, and they launched new features. I mean, Instagram has this thing called Instagram Direct, which is kind of like person-to-person photo messaging, and they built and launched Instagram Direct, including a kind of real-time commenting system based on those photos while we were mid-migration. I think the real-time system that powers Direct was the first thing that we built directly into VPC instead of EC2. And it's like this, it's hey, product teams build new features, great, fantastic. But I think the important takeaway here is that these features are our core business. If we stop people from building these features while we're doing the migration, there's something wrong, right? We want to make sure that these people can still work on the core business while we do the migration. I don't think anyone would be happy if you said hey, you need to migrate from here to here. Just turn it off and turn it back on again in a week. It'll be fine, right? I don't think anyone would ever say that. The fact that we could, transparently make these things and these developments happen at the same time was really good. And we learned that simplicity was important, and that this kind of super hyper simplification allowed us to remove some of the hacks that we'd got in the app server that we weren't hugely proud of, regex parsing for site integrity, really. But we could kind of sit down and do things right once and for all. And simplicity kind of added to all of these things. The speed, the migration was fast because it was simple. The performance was better because we'd rationalized one use case down to one machine, and we could hyper-optimize that machine for a specific use case. The software as a service implementations were easy because we had this simple modular system that we could just replace another component with. The launches, again, we'd simplified the process of building new software out because people were just making changes. It's if people are going to make changes anyway, they might as well be easy for them to do it. There's no real benefit in making people's work harder. And security was simple to integrate with because we used and we built on top of all of the Facebook systems. So the Facebook security people come along and say, oh, so you're still you're using containers, it's going to be great. It's cool. So come on, here's the war story. What went less well? There's two sides to every coin, right? So almost everything that went well actually went less well. So speed. You talk about how fast the migration actually took in each section. The preparation for each section took us slightly longer than we'd hoped. So, we moved from Classic to VPC, and it took 2 or 3 weeks. The process of being able to move from Classic to VPC took a little bit longer, and we'd have liked to have gotten things moving quicker, but I don't actually think that's a problem because a lot of the things that we did as part of that preparation are actually really valuable things in their own right, and none of that effort was wasted. It's not like we threw it all away once we'd moved. The process of doing that preparation was actually set us up for success in the future onwards. Making presumptions. Facebook internally had some presumptions about what happens on their servers, and we kind of violated these. The containerization system presumes that you're going to be running more than one container on a machine. It's like, nope, just one. There's another talk on the schedule about MySQL automation, and like Facebook's MySQL automation is fantastic. And at one point it was like, oh, it's a database server, so it gets automated. And we're like, sure. And then they're like, well, your Postgres doesn't pass our MySQL health check. Wipe it, it's dead. It's like, no. So, a couple of times we had near misses and small inconveniences. And fortunately that one happened pretty quickly, and we hadn't gone too far down that route. But we had some near misses where we hadn't questioned the presumptions that other people were making about the system. We'd questioned our own presumptions and been like, okay, so we are presuming that we can get these machines to 80% utilization and it won't be a problem. Well, what if you can't? And we tested for that, but we also presumed that no one else was going to try and do anything with our machines, and that's not necessarily true. When you have this kind of huge infrastructure behind you, it's kind of a double-edged sword that it expects you to work the same way as everyone else in some cases, and that's not necessarily true. Software as a service. Again, big success implementing new services, inside Facebook, but we had a few near misses from internal services making updates and making changes and testing all the Facebook use cases and not really thinking about the Instagram use cases. So when they deploy the new binary and it takes twice the amount of RAM on the machine, they don't realize that we're running pretty close to our ceiling on RAM. And it's like, oh, you just add a memory to all of our database slaves. Thanks, guys. We should probably fix that. We solve this problem by engaging with those teams as soon as possible. So when someone comes to you and say, hey, I have a great service, I want you to use it, it's like, cool, that's really good. How do I integrate with your service such that we can be embedded in your release and your testing cycle, and you're not going to try and push your service without testing our stuff at the same time? And, I don't know any development team that when you go to them and say, can I write some unit tests for you? They'll say no. I mean, no one likes writing testing. It's a fact of life, right? It's pretty much a fair comment. Making sure that we kind of embedded all of our stuff into their release cycle was really quite valuable for us, and we didn't start this until after we'd moved a few things, and we could maybe have started that a bit sooner. But it's not, again, it's a lesson learned. It's not necessarily a bad experience. Growth. I talked about how well the product grew. The product grew really well. That was fantastic. But the team were focused really hard on this project for the life of this project. We were having to do hard, legitimately solve hard problems, and we maybe took our eye off the scaling of the team a little bit. It's possible we could have worked a bit harder to grow the team whilst we were also doing the migration. But again, I kind of look at it, and we scaled the product from 100 to 200. We launched new features. We did the migration. Kind of growing the team at the same time would have been perfect, but we didn't quite get there. Capacity management. Anyone who's ever done a cloud to on-premises migration will tell you that cloud is awesome for emergency scaling. You go to Amazon, you say, I want another 100 of these machines, and they're like, sure, boom, done. I go to my capacity engineer and say, I need another 100 of these machines, and she goes, I don't know. Capacity planning at Facebook is done in advance. Like, these are physical machines. They have to be ordered. They have to be delivered. It's not necessarily trivial for you to just burst up in a heartbeat. So, understanding these failure situations and how they apply in practice is really important. EC2 abstracts you away from certain failures because you have no visibility into them. How do you know if all of your EC2 machines are in the same rack or on the same power domain? You just don't, right? You just have to trust Amazon that it's going to be okay. Inside Facebook, obviously, we get that locality information, and we get to see where our machines are physically. And maybe they're no more or less physically dispersed than they were in Amazon, but now you can see it, and now it looks scary. And it didn't before, but you have to be aware of these things. EC2 might be no better, but you just don't know. So what can you learn? This is, just to recap. Minimize, simplify, minimize. The fewer the plate spinner has to keep in the air, the more a chance of getting them all to stay up at the same time. And if you can keep it to one or two, that's a really big bonus. You can't necessarily keep it down to one, but keeping it down to a couple is pretty advantageous. Infrastructure as code works really well. Not just configuration management, but like key infrastructure management. How many machines do I have? What do they do? not just what are their roles, but like how do they sit with respect to load balancer pools and so on. Clicking through the EC2 web interface is great, but yeah, get to a few hundred or a few thousand machines, and it's going to be hard. Actually, kind of making sure you can automate that stuff is really good. Transparent tooling. We, at the same time, we had automation for EC2 to do this infrastructure management. We built the same process inside Facebook. Now, Facebook's infrastructure management tooling looks completely different to Amazon's, but there's no reason our wrapper didn't have to. So we went down the process of trying to make sure that these things looked and worked similar, such that at sometimes, you know, an engineer is working on the push system for direct, and he types like IG SSH pushes 5, and it drops him into a shell on that machine. He doesn't actually know whether it's an EC2 machine or a Facebook machine. It's just the right machine. And keeping the tooling transparent so you don't have to retrain 20 people every time you make a change. You don't have to have a big thing up on the board that says, oh, if you want to talk to a slave, you need to talk to Facebook machines unless it's shard 50, which we haven't migrated yet. Like, just make the tooling solve that problem for you. At the same time, things like IP tables, ngrep, netstat, VMstat, all of those things are really useful. EC2 automation and Chef for tooling is fantastic, but when you've got something weird happening and you don't know why, actually reverting to the kind of core Unix debugging tools that you're used to works out pretty well. But fundamentally, simplify. Keeping things simple, make them easier to move. Keeping things simple, make them easier to maintain, makes them easier to update. It's just generally a better thing to do. I would rather migrate a system with lots of simple steps than one or two very complicated steps. I think there's a much higher chance of you getting it right. You know, the likes of Rob Pike and Dennis Ritchie said this years and years ago. Mike Gankarts wrote a book on it. I totally think, you know, it's a core principle of Unix, and I think it should be a core principle of any even vaguely complicated system today. Thank you very much. I think we have time for a couple of questions if you have got. We don't have a huge amount, but just do me a favor when you ask, can you announce who you are before you ask, if anyone wants to?
Do a bit of a speech.
If I did this today, would I just use ClassicLink? Maybe. There are things that, remember I said Instagram are really good at building something, then a couple of weeks later Amazon came out with the same tool, Netty and ClassicLink, right? Like, maybe. I'm not sure how great ClassicLink is at the size that we had. I'm not sure how it's implemented internally. I'd be interested to see how they implemented ClassicLink compared to our Netty, but maybe. Okay, thank you very much.